Today we're going to look at a special method we have for solving some quadratics if they're in the right format, which is solving by using square roots. This method works if you're able to get just x squared on one side of the equation, or n squared, or whatever your variable is squared, and then just a number on the other side. This doesn't always work because if you have regular x terms, then you can't do that. You have to use one of the other methods like quadratic formula or factoring. But it's a really slick way to solve things when they work nicely. So all four of these can be solved by taking square roots. The first thing we need to do is get x squared or n squared, whatever it is, by itself. So here, in this first one, I need to undo that minus 4. So as usual, I'm going to add 4 to both sides. Negative 3 plus 4 is positive 1. I'm almost done. I'm not quite done. I don't want n squared. I want regular n. To undo a squared or exponent 2, I do the opposite, which is a square root. Anything I do to one side, I have to do the other side. The square root and the squared cancel each other out, so I get just n, which is exactly what I want. And the square root of 1 is 1. Technically, the square root of 1 is two different numbers. I can have positive 1 or I can have negative 1. So the shortcut way I write that is plus or minus 1, or you can write that as n equals positive 1 and n equals negative 1. We get two different answers here because 1 times 1 is 1, but also negative 1 times negative 1 is 1. So whenever you take the square root, you're going to get two solutions, plus and minus whatever the square root of this number is. You are welcome to write it the shortcut way, or you can write it out the longhand way. Let's try another one. This time, I need to undo anything that's not x squared. So this means 7 times x squared. To undo multiplying by 7, I divide both sides by 7. When I do that, I get 25 after the equal sign. To get x completely by itself, I need to take the square root of both sides. Squared and square root cancel each other out. I get just x. The square root of 25 is plus or minus 5. Or you can think of that as x equals 5 and x equals negative 5. These two will also work with the square root method, but there's going to be slightly more work because there's a little bit more steps involved to get x squared or whatever it is by itself first. As usual with solving equations, we undo addition or subtraction first. This minus 3, I undo by adding 3 to both sides. When I do that over here, I get negative 220. Now to undo this negative 10 in front of p squared, I divide by negative 10. Negative 220 divided by negative 10 is positive 22. Then I take the square root. I get p, which is what I want here. 22 is not a perfect square. Like for instance, 25 is a perfect square because 5 times 5 is 25. I get a nice lovely integer when I take the square root. If you were to type square root of 22 in a calculator, you would get a crazy decimal. You would get 4 point something. And so if you get a crazy decimal, we're just going to leave it in square root form because it's the most exact way we can write our answer. But we still need to include a plus or minus because it could be the positive version of that radical or the negative version. So our final answer here is going to be plus or minus square root of 22. Like I said, we're just leaving it in square root form. A lot of college professors like this because it's more exact. Last one. Undo minus 6 by adding 6. And I get 282 when I do my addition here. As always, you're welcome to use a calculator to help you out with stuff. You don't have to do this all in your head. Divide by 6 to undo the 6 in front of n squared. When I do that, I get 47. And then to undo the exponent 2, I take the square root. 47 is not a perfect square. When you take the square root of 47, you get 6 point something. And so we're just going to leave our answer as plus and minus the square root of 47. So, nice little easy method to use as long as your equations are in the right format. That is it. Have a great day.